Math 1314, section C87, homework 7, distance, midpoint, and circles. Video 4, writing the equation of a circle, graphing a circle. You all know what circles are. But it's amazing how many people can't adequately define or describe what a circle is. And to make my point, when I ask people what's a circle, they usually say it's a round shape. And then I'll say, all right, circle. And they go, no, that's not a circle. I'm like, why not? It's round, isn't it? Yeah, but, and then they have trouble describing why this does not constitute a circle. So I invite you to pause the video and maybe think of a good descriptive, objective description as to why this thing would not be called a circle. It's clearly not a circle. Now, either you paused the video and thought about it or you didn't. And if you didn't pause it, oh well, trying to give you an opportunity to think. The reason it's not a circle is that if you go to its center, then the distance to the edges is not always the same. This is actually what's called an ellipse. So what makes a circle a circle? Well, the distance from the center to the edge is the same no matter where you go. So for example, the center of the circle seems to be right here. It wouldn't matter if we went that direction or this direction or straight up or kind of diagonally downwards. That distance would be the same all the way around the circle. In fact, that distance has a name. That distance is called a radius. Now, there's actually two definitions of the word radius. From a geometric perspective, the radius is actually any segment that connects the center of the circle to any point on the edge. So everywhere I stop, that's a radius, 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 radius. So you can think of a radius as a line segment. But in an algebraic context, in an algebra context, the radius is just, and I'm going to type this because it'll be cleaner and easier to read if I do. The radius is just the distance from the center of the circle to any point on the circle. So what makes a circle a circle? The actual definition of a circle is the following. A circle is the collection of points that are the same distance from a given fixed point, which is called the center. That distance is called the radius. Radius. Now, being a point, the center is going to have an ordered pair. The radius, however, will be a single number. I thought about going through the discovery process of figuring out the equation of a circle. I'm just going to get right to the equation, but I'll give you a little bit of a sneak peek behind the curtain. The equation of a circle is a direct consequence of the Pythagorean theorem or the distance formula, depending upon your perspective. So without further ado, if a circle has center h comma k, so we're going to go ahead and draw a generic coordinate plane here, and we'll drop a circle on it. Why are my circles red? I don't know. That's just the color I'm choosing. Circle, please. It's not sure why it's not forcing it to be a circle, but that's good enough. But if a circle has a radius of r, so we will draw a radius here. But that was going to be a line segment. That looks good enough. May not be exactly in the center, but it's close enough for our purposes. If the center is at h comma k and the radius is r, then the equation of the circle in standard form is the following. Open parentheses x minus whatever the x coordinate of the center is. And I don't know why the x coordinate of the center is generically called h, but it always is. Plus the square of y minus k. And again, k is generically the center of a circle. I wasn't there when that decision was made. And that is equal to, go back here, you. That is equal to the square of the radius. Sorry, folks, trying to clean things up here. In other words, that's equal to r squared. And if you'll notice, it has remnants of the Pythagorean theorem, something squared plus something squared equals something squared. It's not a coincidence. I invite you to research further if you want to see the connection between the two. But for our purposes, if you have a circle whose center is h comma k and whose radius is r, then you just have to put the h here, the k there, and the r there, and then you've got the equation of your circle. Upon inserting the values for the center and the radius, there's a couple of things to be on the lookout for. Number one, if either of the coordinates of the center are negative, then when you put that negative in there, it will become minus a negative, and therefore you should write it as a plus. And number two, go ahead and square whatever the radius is. Don't let it sitting there with the square on it if you can finish it. All right, so we're going to do a couple of things in this first example. We're going to write the equation of the circle in standard form, and we're going to graph the circle. As far as writing the equation of the circle in standard form, all you really have to know is the general equation looks like this. The square of x minus h plus the square of y minus k equals the square of r. And you have to identify who's who. Because our center is 3 comma negative 2, we have h is equal to 3 and k is equal to negative 2. And we're told that the radius is 5, but I'm going to go ahead and write r equals 5. Then all we have to do is take our equation, write everything the same except the h, the k, and the r. And if you'll notice, I wrote the equation, but I left out h, k, and r because I'm about to replace them with what they equal. The h is 3. The k is negative 2. Proceed with caution there. And the r is 5. Is this an acceptable equation? It is. Is there anything we can clean up? There is. Specifically, never leave a double negative in an answer, and I can square the 5. So a good final answer would be x minus 3 squared plus, inside the second parentheses is where we had the minus negative, so it will become a y plus 2. And then on the right side of the equal sign, it just says 5 squared, which is 25. This would be considered the best answer, the final answer for the equation of the circle in standard form. You might be wondering, well, on each of the squared parentheses, can we write the parentheses twice and FOIL it out? You could. It would make a big mess and it would kill the evidence of what the center was. So I wouldn't do that. We're also going to graph this. So give me 1 second to make some room for it. How do you graph a circle? Actually, graphing a circle is really easy. The first thing you have to do is locate the center. I'm going to do something real quick. I'm going to try to capture all this writing and move it so I have more room for a graph. So we'll put it all right here. There we go. All right. We'll just freehand the axes. All right, so how would we draw this? Well, we could actually draw the equation of the circle by knowing just its center and its radius. We don't need to know the equation. I know the center is 3 comma negative 2. So I'm going to need some room to go over and down. 1, 2, 3, and then negative 2. So there's our center. But how do we draw the circle if we know its radius is 5? Well, remember, all the points on the circle have to be 5 units from the center. So all we need to do is locate some points that are 5 units from the point 3 comma negative 2. And how can we find points that are 5 units away? By moving 5 units in a given direction. What direction? Doesn't really matter. We could go up. Actually, before I do this, let me put some more marks on the axis. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And if you're wondering why I counted to 5, I'll give you a hint. What's the radius? All right, so from, I need a couple more points. Hold. There we go. All right, so from the center, just go 5 in 4 different directions, up, down, left, and right. For example, if I go up 5, I'll go 1, 2, 3, 4, 5. And where does that put me? Looks like it puts me at the point 3 comma 3. If you count it off from the origin, over 3, up 3. If I go 5 to the right, it'll be 1, 2, 3, 4, 5. And it looks like that puts me at the point 8 comma negative 2. And I didn't count the 8. I just knew that I was over 3, and then I went 5 more to go over 8. If I go down 5, 1, 2, 3, 4, 5 right there at the bottom. I believe that's the point 3 comma -7. The 3 is the same as the center because I didn't move left or right from the center. I just went down. But down 5 from -2 put me at -7. And then if I go 5 to the left, it's 1, 2, 3, 4, 5. And I believe this point is at -2 comma -2. I know it's down -2 because it has the same vertical displacement as that point. But to find the x, we just went 3 minus 5 to get -2. I've got 4 points. I can loosely draw a circle. I'll show you how they ask you to do it in the homework in a minute, because obviously they're not going to ask you to freehand it. All right, so with the center and radius, you can build the equation, but you can also sketch the circle really easily. The sketch of the circle just requires locating the center and then going up, down, left, and right, whatever the radius is, to locate 4 points on your circle. All right, there was supposed to be an equation here. So give me 1 second to draw one. Okay, we're going to go with this equation. Determine the center and radius of the circle, graph the circle. Now notice I've already given you an equation. It is technically in standard form. And you might be thinking, but there's not parentheses around the y and there's not another number after the y. Well, you're right, and you're also not right at the same time. If we're going to pull out the center and the radius of a circle, you need to remember that general form looks like that thing in yellow. The coordinates of the center are the numbers being subtracted from x and from y. Let me say that again. The numbers that are the coordinates of the center are the numbers that are being subtracted from the x and the y. So if I can see what's after the minus sign, I just have to pluck it out. There are no minus signs here, at least not yet. Now, what I'm about to show you is a gimmick. You do not have to trick out the equation this way, but I want to illustrate that the center does represent what is being subtracted from both the x and the y. Question: in the parentheses x minus 3, what's being subtracted from the x? Now, if your instinct says there's nothing being subtracted, the 3 is being added, you're correct. But I can write it as a subtraction problem by writing it as minus -3. It's a pretty sleazy move, if you will. Very rarely do you turn a positive back into minus a negative, but I am looking for what's being subtracted from the -3, what's being subtracted from the x. And when you see x plus 3, what's being subtracted is actually a -3. And the same thing for the y. I don't see anything being subtracted from this y. It just says y squared, but I need something that's being subtracted from it. Well, what can you subtract from something that doesn't change its value? 0. Now, do you physically need to draw the 0 in there? Actually, no, you don't. But I wanted to do it this time to show you that there is something being subtracted from the y, even though there wasn't anything following it. And there was something being subtracted from the x, even though there was a number added to it. But now that I know what's being subtracted from the x and what's being subtracted from the y, I can extract that to get the center. And again, the reason I wrote it that way is because I'm trying to make this equation have the correct form: x minus something squared, y minus something squared. The plus could be written as minus a negative, and the y could be written as y minus 0. But now that I've done all that, the things being subtracted are -3 and 0, and that's my center. Now, the fast way to get to the center is to just change the sign on the number following the letter. I see a +3 here, so the center has a -3. Back here, I see a -3 here, so the center was +3. I see a +2 there, so the center was -2. That's really the easiest way to extract the center from an equation of a circle in standard form, is to just take the number after the letter and change its sign. I just did the double negative and the 0 to illustrate where the -3 and where the 0 were. Oh, we're not done. We need the radius. You know what the radius is? It's not 9. Why? Because the number at the end on the right side of the equal sign is not r, but r squared. So if you have an equation that's already in standard form, keep in mind that this value at the end is not the radius, but the square of the radius. But I want to know what the radius equals. So how do we go from r squared to r? Well, this is just a little bitty quadratic equation. We could square root both sides and get that r is 3. From an algebraic perspective, r is plus or minus 3, but radius is a distance, so we're not going to mess with the plus minus. All right, so our center is at -3, 0. Our radius is at 3. Let's get this sketched real quick. Let's see, our center is at 0, -3, so we don't need to go left to right. We need to go down 3. We'll put a center there. And since our radius is 3, we're going to go 3 in each direction from there. So we're going to go 3 up, 3 down, 3 to the right, 3 to the left, and locate our 4 points. If we go up 3, it'll put us right at the origin. If we go to the right 3, it'll put us right there. If we go to the left 3, it'll put us right there. If we go down 3, it'll put us here. It's much easier to do on graph paper. And there's our circle. All right, before we get to the last slide in this video, I actually want to share what a homework problem would look like here. So give me 1 second to go to my student version of the assignment. You should be able to see this now. For example, this is number 7, or a version of number 4, excuse me, on homework 7, where you're given an equation in standard form and asked to determine the center and radius. Don't believe you're being asked to graph this one, so let's go to one where we do graph. Actually, let's do this one real quick. Do you know what the center is? Hint, pull out the numbers after the x and the y, but change their signs. Since the number after the x is +3, the x coordinate of the center is -3. And since the number after the y is -4, the y coordinate of the center is +4.